Welcome to this morning's session. Yay! It's Thursday, you're still here.
That's how we want it. Round of applause, yeah. Energy.
So we're obviously in the best room, because we're going to be talking security all day here, which is wonderful, at least this morning, and then I think also this afternoon. I'm Maya. I was on the program review committee, and I'm your track host this morning. And I'm here to introduce Liz Rice, who will be talking about DIY Kubernetes pen testing. Liz is a technology evangelist at Aqua Security, and I'm sure you've seen her many times before. She used to be the co-chair for KubeCon, and you've seen her on the big stage. Please, just a reminder that if you have a seat next to you, kind of move in so everybody can have a chance to sit. And make sure to rate the session on Shed after their talk. And if there's time for questions at the end, I'll be running around with a microphone. Please, Liz, take it away.
All right, thank you very much, Maya. There are some seats, quite a few seats in this corner up front if you're looking for one. All right, so thank you so much for coming to this talk about DIY penetration testing for Kubernetes. I work for Aqua Security, and we help enterprises secure their Kubernetes deployment. But we don't offer penetration testing services. It's something that specialist companies offer. And penetration testing is where you kind of act like a hacker. You see what you can do to exploit a deployment. And there's a whole set of tools that both hackers and pen testers will use to explore what's possible, to kind of scan what ports are available and then run various different types of tests to see what you can do in a deployment of any kind, not just Kubernetes. This is like a set of just some of the tools that are available. Nmap is one of the most famous ones. So famous it actually has a whole page on its website about Nmap's use in movies. So this is from Matrix Reloaded. And it does actually say Nmap there. But you don't necessarily want to, if you want to do it yourself, you don't necessarily want to have to ramp up on these tools. If you're a busy Kubernetes administrator, this is a whole specialist skill doing penetration testing. The reason why you might want to do some kind of pen testing is because of stories like this, where just over a year ago, bit over a year ago, there was this situation where Tesla had rather unfortunately left their Kubernetes cluster open to the internet, and that left the dashboard open to the internet. The dashboard had cluster admin privileges, and so basically anybody who found that dashboard was able to do things to their cluster. What they chose to do was do some cryptocurrency mining. And when this happened, we thought, well, a little bit of basic penetration testing, a little bit of kind of just checking what's possible out there would have helped Tesla and maybe other companies out there see if they'd done anything kind of grossly misconfigured, like leaving a dashboard or the API open to anybody to abuse on the internet. So we wrote this tool called KeepHunter, which does some of this penetration testing, specifically looking for misconfigurations in Kubernetes. It's not in any way, a replacement for a full penetration test, but given that penetration testing can be pretty expensive, it's nice to have something that can check for open issues, open ports, and so on. So what I'm going to do this morning is show you some of the things that are happening inside KeepHunter, like what are the sort of types of attack that KeepHunter is going to try for you, which you could type in on the command line the same way as I'm going to, or you could run KeepHunter. Generally, the principle is it's looking for open ports, mostly looking at the default ports that Kubernetes components may or may not have left open. And it's attempting to make REST API requests when it finds open ports. That is not a comprehensive set of penetration tests, but it will help us find some potential issues. Before we talk about exactly what kind of tests there are, I just want to reset a little bit about making these RESTful API requests. So you could be making them over just plain old regular HTTP, or you could be using HTTPS. Now, lots of software, Kubernetes components included, they're offering an API, they're acting as a server for that API. If you want to offer HTTPS, you have to be configured with a certificate that identifies your service. And maybe that's a little bit of a pain to set up, so quite often software is written with an HTTP port as well, just to make it easy to set up and easy to run. Many of the Kubernetes components offer both a secure and insecure port. The reason why you have them on 2 different ports, by the way, is that HTTPS connections start their life as HTTP and then get promoted, upgraded to include the encryption part. And that means you can't offer both HTTP and HTTPS on the same port. So if, as a hacker, we find an HTTP port open, that's kind of, nice. Even if we find HTTPS port, anybody can access that. Anybody can issue API requests over that. Perhaps the API is going to ask us to identify ourselves, or the connection is going to ask us to identify who we are as a client. And perhaps it's going to go further and actually check that ID against a set of permissions. In Kubernetes, we have RBAC for this. So you have to identify yourself, and then the service is going to check whether or not you have permissions to make the request that you've made over the API. So what I'm going to do, I have a cluster here that is terribly badly misconfigured, and I hope none of you have a cluster that is as badly misconfigured as mine is. Over the last probably year, 18 months, lots of work has gone into Kubernetes to make it have better defaults. So some of the things that I have opened up, that's not how the default installation will appear, but it's always worth just checking. If you've got a cluster that's maybe 2 years old, maybe it does have some insecure ports open. All right, so don't configure your cluster the way that I do, because it's very foolish. I'm going to start by looking for an insecure port. So I've got a single node cluster running in a virtual machine. Is that big enough for people to see? Shout if it's not, or wave. OK, let's make it a bit bigger. Right, I am just going to use curl, and I'm going to, I happen to know that 128, actually, I'm going to go back and find it because I might get the address wrong. Right. So I'm just going to do an HTTP request. OK. On port 80, which is the default, there's nothing there. Connection refused means the port is not open. If I was an attacker, I might just issue a curl request to see whether there's something there. Port 80 doesn't come back, I might try port 8080, which is a very common port to be used for services. And as an attacker, if I saw something like this coming back, I would immediately have a really massive clue that it's running Kubernetes, and that might help me decide what I'm going to issue next, what kind of requests I'm going to issue next. I could start looking at the API and getting back enumerations of all the entry points that I could hit. And maybe I could try to get a list of the pods in the default namespace. And I can, because this insecure port has been left open. With this information, I get to see exactly which container images are running. And as a hacker, that would be amazingly useful, because I could look at if I know exactly what images are running, I might find that some of them have vulnerabilities. I can look them up against some databases of vulnerabilities and perhaps exploit some if I find that a container is running that has known vulnerabilities. So being able to access that information could be hugely valuable to an attacker. All right, so that was the insecure port. You can and should be configuring your API server to not leave the insecure port open. OK, so what about the secure port, which runs by default on 6443? And I could, let's issue them at 6443. Now, as an attacker, I don't actually care. Oh, that's come out. It needs to say HTTPS. As an attacker, I don't actually care whether the web service is identifying itself or not with a certificate. But this error is telling us that my client doesn't recognize the certificate from this service. Well, that's fine. I can just specify that I want the insecure version, which says I don't care what certificate I get back. OK. OK, so on the secure port, this is the same cluster. I get a 403. I don't have the authorization to make that particular request. So when you make a request of the Kubernetes API server, if you don't identify yourself, it will be associated with this service account called System Anonymous. So that's a kind of identity for anonymous requests. That service account can be used in RBAC, so you can give that service account permissions to do things, should you so choose. You probably don't want to do that. You might also be wondering, well, should we be allowing these anonymous requests at all? There is an option that allows you to turn off, to disallow any anonymous request. But there is, the thinking goes that if you're going to do things like health checks, you don't necessarily want the client that's making the health check to have to identify itself, to have to set up certificates just to be able to do things like health checks. So by default, anonymous requests are accepted, but it relies on RBAC to stop you from doing anything kind of crazy. All right. So we could do things like get health information, and we get back an OK. So as an attacker, I would at least be able to tell with the default settings that the Kubernetes cluster was up or not. OK. So what if I were able to identify myself as something other than the anonymous user? What if I were able to get hold of the credentials to make a request under a service account that has permissions to do other things? Well, every pod is running under a service account. It might be the default service account, or you can specify another service account identity. And by default, the token associated with that service account is accessible from your application code running inside that pod. The reason for that is so that if your application needs to make requests of the Kubernetes API, it can have the credentials to do so. So if I'm going to run this on my other machine, I've got a kube control, get pods. I have got a pod running, and I can exec into that. Exec curl, and I'm going to run a bash shell inside there. Now, I can get hold of, if I can type, I can get hold of a token from the well-known location, oops, start that again, of the secret. So it's in var run secrets, Kubernetes service account token. So that is my token that's accessible to this particular pod. And if I'll do the insecure version. If I make a request of the Kubernetes API without identifying myself, I get a 403 forbidden message. But if I do the same request, actually, no, let me do it again with trying to get some pod information, namespaces, default pods. So I get a 403 for that request. But if I pass in that token or authorization header, authorization, with the bearer token, that particular service account happens to have permissions to access the API. So if I were an attacker and I had been able to compromise that application, if I'd been able to open a reverse shell, I would have been able to access that token and hit the API and do whatever I wanted to do. Okay. All right. So, yeah, if your app is compromised, your attacker is effectively able to sit inside your app and get hold of that token. Another way that you might be able to get hold of that token is by accessing the secret that it's associated with. So if I go back to my node, right, if I get the secrets on this cluster, there's a secret here called superpower token. And I could describe that. And I can say that is exactly the same token. Now, as a user of the Kubernetes API, as a kubectl user, I might have permission to read secrets. And if I can read secrets, I can get hold of that token. And then I can get all the privileges associated with that service account. So even if it's essentially a way of escalating your privileges. Be very, very careful with your RBAC configuration and who is allowed to access secrets. Access to secrets could be effectively giving access to a broader range of RBAC than you really wanted to give. So everything I've done so far was on the Kubernetes API server. There are several other APIs offered by components within your Kubernetes cluster, which probably are not accessible. They're probably not made available, but you might want to check. So for example, etcd is running on your cluster, and you might want to check whether or not you can access port 2379. And if you make an API request like that, you can tell as an attacker that etcd is running, and you could explore the etcd API and get all sorts of information about the running cluster. Maybe you could even modify the state of your Kubernetes cluster through etcd. Another API is the Kuebler API. So every node is offering up this Kuebler API. This is another example where there's a secure and insecure version, by the way. And the secure version runs on port 10250. Even if you get a 404 page not found, as an attacker or a pen tester, that does tell me that the port is open. So maybe I want to explore that further. And I might do something like, I might try to get some metrics. OK, I don't have permission to do that. What if I have a token? If I'd been able to access a token from a compromised pod or through a secret, I could do exactly the same approach as I did before, pass in that token, authorization, bearer token. And again, there's all sorts of interesting information accessible over the Kubelet API. I could even get information about the running pods on that particular node. So it's not just about the API server API. There are all sorts of other APIs in your cluster. You might want to be checking whether people can get information from them. So I've run a whole load of curl requests. Obviously, that would be a bit painful to do kind of manually if you wanted to do it repeatedly. So we wrote KeepHunter to kind of automate all this kind of thing. So let me run KeepHunter against that cluster, 172.28.28.3. And that's running a whole load of tests, very much along the same lines, very much like issuing those curl requests. And it's found a whole load of interesting things, including, well, it tells me that it's found ports offering API services like the Kubelet API, etcd, and an insecure and secure version of the API server. And then it attempts various things and reports back on them. So, for example, it said, yeah, I've been able to list pods as an anonymous user. OK. You can also run KeepHunter inside of a pod, and then that's simulating what we did before, where you're, if you have an application that's been compromised and you can get hold of the token, well, KeepHunter will try to grab the token and attempt to make requests using that token in this pod mode. The results you get from that will depend on the particular service account that you're running the pod under. So you might want to run KeepHunter inside a pod under all of your different service accounts if you were going to be really comprehensive about it. Everything I've shown you so far is what we call a passive hunter. So I'm just requesting information. I've not done anything that could change the state of the cluster. KeepHunter also has some, or we call them hunters, that do things that could potentially change the state of the cluster. We don't have anything that does anything horrendously destructive, like trying to delete all your pods or something. But we do have some active hunters that will try to create things and then destroy them again. Excuse me. So I could run this again with active mode. 172.28.128.3. And this time, we find a few additional things. You know, it has actually tried creating cluster role and created a privileged pod. And this would be something you want to do with caution. As I say, we're not trying to do anything terribly malicious with these active tests, but you should be aware that it could change the state of your cluster. So, having a quick look inside the code, it's written in Python, and it uses this quite nice observer pattern where I'm just sort of taking some extracts from code to sort of illustrate how this observer pattern works. It works on the basis that you subscribe to events, and you can have classes that subscribe to these events and then can go on to perform more tests. So there's an event for each IP address that we want to test called new host event. And for each host, the class would go through a set of ports. We're looking at for the ports that we expect Kubernetes services to be running on. And for every port where it finds that the network connection is potentially open, it publishes an event called open port event. And then we can have a set of classes that subscribe to that event, maybe specifying particular conditions like what the port number is. In this example, a kubelet discovery hunter that subscribes to open ports for 10250 and 10255. And it will do lots of things, one of which is attempting to read the metrics from that connection. And if that succeeds, it'll say, okay, that's a read kubelet event, which can then be subscribed to by another class, which will attempt to get more information from that kubelet port. Publishing event, for example, if it was able to get hold of the Kubernetes version, that also publishes a vulnerability, and that's what we end up seeing in that table of vulnerabilities. And the reason why I'm showing you that code is because I'm hoping that some of you in this room might have creative ideas for additional hunters. It's open source code, right? I don't think KeepHunter is ever going to be so comprehensive that it would replace a full penetration test, but there's certainly, we have some ideas for some more hunters. Probably people in this room have even more creative ideas for more hunters, and we very much welcome ideas, implementation of hunters as well, if you so choose. So if you are interested in running or contributing to KeepHunter, you will, of course, find it on GitHub. I think we have a little bit of time for questions. Oh. Thank you so much.
Hiya. Is it set up to use from CI? So you were running it manually there, but if we wanted to run it as part of like a continuous delivery pipeline, how set up is it for that?
I haven't tried doing that myself. I guess there's no reason why you couldn't. Yeah, why not? Just, yeah. It's Python code. Just run it wherever you want to run it.
Hi.
Hi.
It was a nice talk and it's nice projects. And do you plan to extend it with, just to use it with some threat pattern databases, or just like tests for CVEs or something like that?
Right.
Or we should just join the project and develop it?
Yeah, I mean, we don't have a particular boundary where we'd say we'd never have that particular type of testing. In fact, just this week, we were talking about the possibility of, if you get back that container image identity, the hash of a container image, as Aqua, we have our own vulnerability database, so we have that information. So we were thinking about maybe potentially adding that. It's just at the idea stage at this point. But yeah, and also, there are plenty of other types of attack that are not currently, it's all just RESTful API attacks at the moment. So we haven't, at this stage, got anything that tries to attack the application code that could be running in your Kubernetes cluster. There's all sorts of possibilities.
Hi. How often do you actually see this sort of insecure ports being opened with your customers?
I don't have data on that. It is definitely the case that there are people who have found, particularly with an older cluster that's been set up for some time, misconfigurations are possible. I would say that perhaps more common is RBAC settings that are a bit looser than they necessarily need to be. Yeah. It's the sort of thing as well, you saw how long it took to run KeepHunter. It's a few seconds and it might save your bacon.
So there was an effort to get better defaults for Kubernetes API.
Yeah.
Is there any plan to test all these popular additional components like Istio or Linkerd that expose more APIs, and we don't know about the status of the defaults.
I think that would be a great thing to do. Yeah. I'm fully supportive of that idea.
Any other questions? All right.
Well,
Thank you
so
again,
much.
Liz.
Thank you.